All right, this is the July 27th session of Mentor Talk. So these will be up on YouTube after the fact, but we'll have people chiming in and stuff. This is just a discussion with Texas mentors and different FRC mentors from around the state, helping each other and showing off different techniques and kind of getting through this time where we're apart from our teams as well as we can. Today we have Scott Brondel from the Howdybots, discussing how they've been able to do remote robot driving and remote practice and work. And then we'll also have some discussion with Andrew Hartnett leading us through how we do some remote training and using Google Classroom and other virtual training techniques. So to start us off tonight, Scott, go ahead and take us away.
All right, final match check. Can everyone hear me okay? Mostly?
Mostly. It was a little weird there, but
yeah,
I
it's still
think
being a little jumpy, but I think if it's the best we can do, it's the best we can do.
Okay. All right, so as Alan mentioned, I'm going to try doing everything just through my video feed instead of actually sharing a screen. So I've got some videos embedded. I'm going to do some live driving. So if you just right-click on me and do a pin, that should make me blow up, and then you can see everything I'm presenting through the video feed. Okay, so what we're going to talk about is remote drive stations. But first, a little about me. My day job is I work for Microsoft. Up until a couple weeks ago, my title was Senior Premier Field Engineer. I'm now Senior Customer Engineer. Microsoft just internally had its biggest reorg in history, affecting about 20,000 people. So I just got a new title and a new manager out of it. But what that means is, in my day job, I work with customers primarily focusing on their core infrastructure, Active Directory environments, and security, and helping them tighten things up. So my job is kind of keeping companies out of the newspapers, trying to be proactive so they don't get hacked. And occasionally I've had to help with the cleanup as well, and I've been involved with some that you have read in the newspapers. They are not fun, let me tell you that. My experience in FIRST. When I started with Microsoft was actually when I first got involved with FIRST. One of the people on my team, their son was in FIRST Lego League, so I got roped into being a judge for that for a couple of years. And after that, I have a daughter who is, we homeschool our kids, and one of them found out about the Howdybots kind of being homeschool friendly. So she started her fourth year right now for the Howdybots, and I'm starting my third year as a technology mentor. So what I do with the Howdybots are things like videography. Here's a picture of me in Evan's living room from last year when we were doing our live streaming telethon. I also do quite a bit of 3D printing, helping out with that for the team. And actually, this year, we developed our own little scouting app that was mostly me on the code, but working to requirements. So we only got one event to play with it, but that's been a fun practice, and we got a nice framework to go on in the future. And one of the things that I kind of like to do is I ask this question a lot. I wonder if, because I'm still new to FIRST robotics, I have, before I went to computer science in college, I have a chemical engineering background. I got out of that, but still have some interest in that. So when I see things, it's kind of like, I wonder if there's a different way of doing it, or I wonder if there's some way of putting in some technical skills to help solve a problem. So that's kind of what evolved into this talk. So, common problem. Something I'm sure we all heard. How often do your non-mechanical students never seem to get a chance to do things on the robot? This never happens, right? They're always trying to get time on the robot because normally mechanical is going nuts, fixing things, adding things, optimizing. So COVID actually is kind of leveled the playing field a bit. Now, none of us can really touch the robot. These images I got from Reddit and Chief Delphi, so yeah, we have lonely robots. So now since we're having to move towards a remote everything, remote teaching, remote learning, remote working, is there any way we can extend some of these things that we've had to get very involved with and learn quickly and apply some of these techniques to allow us to drive and add code to the robot from home, free if we can, and can we do it safely? Can we actually let someone in their house drive a robot sitting in a shop or in your school and not kill things? some research into this. There are several options out there that are commonly used for sharing a Windows desktop. Some of them are free or have extra features you can buy, TeamViewer, such like that. VNC is used. There's also the native RDP, Remote Desktop Protocol, built into Windows. I have a little asterisk on that because in order to connect to something, the piece of hardware that's going to be connected to, that needs to be running Windows 10 Pro. Home Edition is not good enough to connect to, but Home Edition is good enough to connect from. So I can connect to a Windows 10 Pro from a Windows 10 Home. So if any of you, once we get through this, if your drive stations are currently Windows 10 Home and you'd like to try it and you need Windows 10 Pro, ping me offline. Working for Microsoft, I happen to have some really cool discounts, and as long as we're talking, low quantities, I'd be happy to help you out with my discount on that. So, for us is, several of these things allow some limited USB, like RDP will let you actually stream a camera through an RDP session, but none of them will let you do a game controller. Joystick, Xbox, PS4, whatever, that particular USB class is not passed through these options natively. So I started looking into what options are out there, because I know that it is possible to pass Xbox controller through a remote session, because with our testing, I've been involved with some of the Project xCloud, if you heard of that. I've seen that in action. I know it works. There are other services where you can basically rent a high-powered workstation with a good video card in the cloud and play games over that, and you're passing your controller through there. So I knew this had been solved. It was just what's available. So there are some pieces of software out there that are either you must pay or only have free trials. So that didn't kind of go with the trying to keep it free. Also, now you're dealing with two different streams. You have your video stream and your Xbox controller stream, whatever is passing that. So in some instances where you have to do VPN, now there could be non-standard ports involved. So I wanted to try to stay away from that as well. So I kept searching, because this is something that it seems like there has to be a free solution somewhere. And it turned out the free solution exists, and it was sitting under my notes. Another engineer in Microsoft has developed a plugin combined with some other free software that allows you to pass through an Xbox controller over an RDP session. So this is why I started investigating. Microsoft RDP Gamepad plugin. It is a free download, allowing you to use an Xbox controller over RDP. So I have an Xbox controller connected to my system. I RDP to the drive station, and all of a sudden the drive station thinks it has a native Xbox controller hard-coded into it. And it utilizes another free thing called the Vijim Bus Drivers, which is a really fun acronym. It stands for Virtual Gamepad Emulation Framework. And that in itself, it's a really cool software package. It is free, and it'll let you do all kinds of emulations. If you want to play a joystick game, but you don't have a joystick, you can actually map keyboard to the joystick buttons, or vice versa. Or something that requires a PlayStation controller, or you can have an Xbox One mapped into a PlayStation controller. Lots of different emulations involved with it. We're not using the entire framework for this. We're just using what they call the bus drivers. And the bus drivers will let you natively emulate an Xbox 360 or a PlayStation DualShock 4 controller. So the Microsoft guys took that bus driver and created this plugin, which will allow you to plug in an Xbox One controller to your box and make it look like an Xbox 360 to the drive station. So you have a couple of limitations with that. First is it only passes through one Xbox controller. So if you do have multiple things plugged into your system, only one of them is getting passed through. So if you do want to be doing tests that require both sticks inside the drive station, you're going to have to be moving things around a bit just to figure out what's going on. You have to only do one joystick at a time. The second thing is that you must have a wired connection. Xbox controllers can do Bluetooth, or you can buy an Xbox wireless adapter. So you do have to have that a wired connection and not do wireless for this case. Any questions, chat so far?
Hey, Scott, not that it's a big deal, but just FYI, your video is also blocking out part of the thing. So I don't know if you want to turn your own video off or if you are able to move your video over, or something. I don't know. But some of the words are cut off. Yeah.
Like that?
Yep.
All right. Yeah. Thank you very much for that. So this is how I set up a proof of concept to see if this was worth doing. On the right, you have your standard robot network. Get your Roborio, everything powered on, and we have the wireless network coming off of that. We get our drive station connected wirelessly to your robot network, as we standard do. And we also connect your drive station via Ethernet to a network that we can talk to. Because we need to be able to RDP into that drive station, and we're talking about remote connections, we can't have someone in their house not easily get into the wireless network of the robot. So I chose to just have the drive station to be dual homed. 2 network connections, one wired with quote unquote internet access, and then wireless to the robot. Then to simulate the home student, took my phone, put it into hotspot mode, and connected a system with an Xbox controller to the wireless network off the phone hotspot. And then we VPN'd into the shop network and did an RDP connection over that. So in terms of trying to simulate latency and worst case scenario, this is a pretty good test. We have Wi-Fi over a phone through VPN, getting to a system that in the proof of concept was 2 feet away from the drive station, but taking a very round path to get there. So the results we got out of that, the expectation was kind of, this should work, but there are definitely concerns on latency, how responsive the controller is going to feel, and also how granular the controller is going to feel. Because often we're tuning to have very fine level of control. So would it lead to a jumpy feel? Like I have to move a little bit, and the robot does nothing, and then it takes off. We wanted to try to avoid that, but we were worried about those types of concerns. So we hooked this up, gave it to the students to drive, and the actual results were very impressive. Really shocking. If you could feel anything, it was very, very slight. So it was almost as good as plugging in directly. So we actually did a good test in that and spent a couple of batteries driving full speed, and it all worked with the driver having full view of the robot, because you're still physically in the shop, just taking a very long-term path to control. So we proved that this concept for driving could work. Now we had to figure out the remote vision piece. So first thing we looked at, what vision do we currently have on the robot? For our bot this year, all that we had was the limelight mounted on the turret, so it's actually facing upwards a bit. So it's not going to be very handy for helping actually drive because of the angle, and just because it's on a turret that is also rotating, it's not going to be usable for actually controlling the robot. So we first just added a camera that's pointed at the field, a hardware IP camera connected to the network, and we could access it over VPN. We just pointed a VLC to it as a network stream and said, show us the whole field. Unfortunately, the processing inside that camera takes about 1.5 seconds. So it could work, but you are not driving fast, and you're having to drive in spurts. Move a little bit, see how far you went once the camera picked up, move a little bit again. So it's enough to do something, but definitely not a good optimal driving experience. So that gave us some new requirements. We definitely need faster response, and we do need something that is robot-centric. Can we get a front and a back view actually mounted on the robot itself? So did some investigation on this and came across a really cool Raspberry Pi distribution called Motion iOS. This is also available as just a package you can install on a Pi and a few other devices as well. And its purpose, it was built to be a do-it-yourself motion detection. If you're just having various cameras and you want to do your own security system, if there's any movement, send an email, take a picture, take a video, upload it somewhere, it's able to do all that natively. And the nice thing is you can have physical devices mounted into the Pi, or you can also say, here is an IP feed from an IP camera, and monitor that, stream it down, and if you detect changes, perform the same actions. So it's really flexible. And its interface is a web page. So with that, we were able to actually view multiple cameras at the same time on one browser page. So when we started testing this, we started off with just bringing in one camera. So what you're seeing here on the left is the MotionEye web browser. And on the right, you're seeing that full field camera that we set up. And I set one of the students to just do a little quick driving just to see what the difference in responsiveness was. I heard the audio break up as well, but yeah, the student said that the MotionEye over here was better than this thing. It's the lag on the MotionEye is typically about a quarter second, at most a half second, but it does pretty good. So then we set up a full 3 camera view. So what you're seeing here is we have a camera set up for the front of the robot, a camera set up in the back, and then this is the Limelight feed. I said that it could actually pull in physical and IP cameras. So we were able to pull in the Limelight feeds, so now we have a front, back, and Limelight through one interface on the drive station. And this is another view of that. You can see the cameras here, but you also see the robot in the background, so you can get an idea of the responsiveness. So what we did was, adding into this, we now added a Raspberry Pi and a couple of cameras, and we added in an IP camera, still giving the full field of view. And then we actually gave this to a student. I had them install the client software they need to connect. We got them VPN'd into our network, and then I called them up, and we just kept in voice contact over cell phone while we let them take the reins and see how it worked. So the results we got out of this, we got some unexpected results. We didn't plan on measuring the latency of the cell phone network, but we were able to calculate that the latency of the cell phone network is about 2.5 seconds. And we measured that by how long it took for me to scream stop before the student actually reacted to that, and the robot stopped moving. So we did have a few close calls with this one. Part of it was we didn't have any throttling on the robot yet, so the robot was still moving full speed, and the student didn't adjust for how much he was pushing the stick and how fast that was going to make the robot take off. So it turned out to be a little bit workable, but there are some caveats. We do need to be thinking about adding in a throttle so that we know that the student is going to be moving the robot slow enough so if things do go wrong, the student can see it and react to it on time. And we also need to make sure that we still have the ability for a local student or mentor at the shop to have an e-stop. One disadvantage of doing RDP is when I RDP to a system, the actual monitor on that system locks, and it takes away the keyboard as well. So I can bang on the spacebar or the enter key, and nothing happens because the control has passed all the way to the remote student. So how do we get some emergency stop capability back to any local mentor? One way we tried it was, since the student is connecting to the Ethernet cable, let's just unplug the Ethernet cable. And that does stop the robot, but it actually takes about 1.5 seconds before the drive station realizes, from its perspective, the Xbox controller was unplugged, and I need to stop the robot. So that was too much delay for our liking. We wanted to try something a little faster. Try just setting up the power button or closing the lid, making the system go into sleep. And that, unfortunately, was inconsistent. It wouldn't always go into sleep every single time. So that wasn't deemed enough to be reliable either. So we found one very reliable and quick way of doing it, which is having another system locally at the shop that can remotely kill the driver station.exe process on the driver station system. Once you kill that process, the robot stops dead in its tracks. So how do we get a process killed? There are actually quite a few ways of doing this. And some ways are going to be dependent really on what is the configuration of your system, what are you allowed to modify, is it joined to an infrastructure or not? There's going to be quite a few variables here. So this is going to be, your results may vary. Again, there are many ways to do it. If you get down to this point and need some advice, feel free to reach out. I'm going to go through the method that we chose with our systems, just being all work group connected and how we did it. But your end goal is have an always ready command line sitting on a system waiting for you to hit enter that will immediately kill that driver station process. So how we chose to do it was get another laptop onto the shop network, the same network that your driver station is hardwired to. We used the free PSExec tool from Microsoft, one of the older free sysinternals tools. And we use that to launch a command prompt that is running on the driver station, but just the command prompt text is on my system. So you can almost think of it as mini RDP just to run commands. And then we just want to have a command sitting there, typed in, ready to hit enter on. There's the built-in command called task. /im says match anything with this image name, driver station.exe, and /f2 force it. So I just type it in, finger on the enter key, and if the student's drives and they're starting to do something bad or they're about to hit something, then just hit the enter key and that robot's going to stop. So once that's ready, you can have fun messing with your students. That can be fun as well. And again, there are many ways of doing it. If you actually have a managed Active Directory environment, you can actually do this with built-in PowerShell in Windows. Just find a way that works with your particular management infrastructure, admin accounts, firewall rules, all of that come into play. So, giving us the final view. We're taking in what we have built on, and now we're adding in an e-stop system, and just having a command ready to do a remote kill. Any questions so far?
How many legs were broken in the process of testing this?
No humans or animals were killed in the testing of this yet.
Oh, yay. We didn't hurt any bunnies.
That's correct.
What are you using for your VPN tunnel?
How we are set up actually is the way our network is configured. We have some things that are running in cloud space in Azure, one of those being just a Windows server, and we are actually able to VPN to that Windows server, and then we have a tunnel from our network to that network the VPN server is on. So we VPN into Azure, and it redirects back into the shop.
Okay. Yeah, this could be maybe talked about some later, but I know that I'm trying to think of like, okay, if I were trying to coordinate with a school district, what kind of ports do I need opened up in their firewall and all those types of things to be able to connect up to a computer in there for a remote desktop. But because I am not a networking person by any means. But yeah, okay.
Yeah, one possibility would be to run run something in Azure or another cloud so that you're VPNing out to a common network instead of trying to have them VPN back in. Does that make sense? So like you could actually
Conceptually,
have
that
your,
makes sense. But
yeah,
how I would actually go and do that, I would definitely need to go get smarter on some network things.
yeah. It just might be a lot easier for your network admins to allow you a tunnel to initiate a tunnel outbound rather than the inbound route.
True. All right, so the results of this. How does it look? Let's see if we can use some of Austin's demo god luck from last week, and we'll actually give this a bit of a shot. So, what you're seeing right now is a live feed from the desktop of the drive station. So this is the system that is actually connected to the robot right now. The robot is live but disabled. And we can see that we do have 3 different views here. So we have, this is actually the back view, and then we have the front view with me. Hi. And this is our limelight that is locked into the hexagon here, looking at the reflective tape. And I'm also going to show you here on the task schedule here. This is the current bandwidth being used on the robot network, on the Wi-Fi. And I want to point this out because when you're setting up these cameras, you can set for each camera that you bring in what your desired resolution and frame rate should be. But then if you actually were in a competition and you're worried about how much bandwidth, in the settings of this, there is this nice kind of master switch that will let you do everything at once. So I can bring down frame rate and bring down resolution, and you can see that instantly has a pretty massive effect on the bandwidth. So you can use this and actually do some really cool, quick, on-the-fly tuning to make sure that you're getting things good enough to be able to be used, but also limit down if you think you are having some issues with actual using it on the field. Okay. Now, what you're seeing here is the actual, what we'll call the student system. So from this system, I'm going to open up a MSTSC, that is the RDP client. And I'm going to connect to the address of the drive station. So when I make this connection, now we are RDP'd in, and you are seeing the quote-unquote drive station. So we just made a live connection. And if I go down to the USB here, you can see that we have a Xbox 360 for Windows that is showing current. That is the emulated stick that is being passed through. You actually see a camera view. Here's the stick, and here's that system. You'll notice that the system on the left is now just locked because when I RDP'd in, that system basically did a lock screen. So that is why the spacebar here, all it's doing is trying to take that as input. It's no longer being passed to drive station, which is why we needed the ESOP capability. And speaking of the ESOP, now I'm going to show you, here is my system that I'm talking to you guys from, and I'm ready to PSExec into that drive station. So now I have a prompt running on that the drive station, and I'm going to get ready to kill the drive station. task kill/m /f force. So let's go back to the student system, and we'll actually enable the robot and do some driving. Here's what the camera view looks like.
Scott, this may be a silly request, but would you be able to actually like hold the controller up in the field of view here and then like push forward on it so we can see that? Yeah, we can
Is this
see
good?
it. Yep.
All right.
That looks awesome.
All right. Now, one last bit. Let's actually see the task kill in place. So I didn't get a split screen for that set up, unfortunately. So I'm just going to do some driving. And from this view, you can see the drive station window here. So I'm just going to drive slowly forward, and then I'm going to hit enter to kill that process. Is dead. Anyone want to see the kill again?
I don't think it's needed, but we were able to see that it worked.
Yeah, it seems
Yeah, that was pretty definitive.
So to get it going again, you just have to reopen the driver station?
Repeat that again, sorry.
I was just, what you're just doing, I was just wanting to see to get it going again, you just reopen the driver station?
Yeah, because it's as if I am there, just I'm touching a different system's physical keyboard. So, back up a little bit, and 3, 2, 1, death.
And that'd probably be something you could set up an alias for, right? So that you don't have to, because I feel like it'd be easy to accidentally misspell something, have it sitting there and not realize that you have it spelled incorrectly
It's a
somewhere.
good thing for, just have it set up, and like before you give it to the student, just have it there ready to go, because then I can just hit up, enter. It's not currently running, but as soon as next time it is running, I'll just be able to kill it.
But you should be able to have you could have an icon or something that you could key map or anything too, right? Like there's no reason why you couldn't.
Yeah,
You can,
making this a more streamlined experience is definitely an exercise for the reader.
It's just a command line prompt, right? Like there's no reason you couldn't.
Right.
It could be anything.
You can make a big red button and attach it to a Raspberry Pi.
Yeah.
Sure.
One reason I did it this way, though, I had this initial connection. This is what's giving me the command prompt that I can then kill from. So I set this up first, so I have an always-on kennel, so I'm just ready to hit enter. Now I could send, say, psexec instead of cmd to open up a shell. I could send that whole thing, but didn't just realize I have to build up psexec first, then this kicks it off. So that's going to add about a quarter, third second. So for the most immediate path, I went this way. I could do it all in one thing, which would then make it literally something that I could double click on to launch, but that is going to add a little bit of delay into it.
That makes sense.
That makes sense.
how do you get all this stuff? Don't worry about getting all these links. Get this last one. If you go to aka.ms/frc-wan-drive, I've set that up to redirect to a public OneDrive share I've made, where I have this stack and the current releases of all of these tools, so it is all there ready for you to go. And I will get that into the chat for you as well. So definitely encourage you guys, go take a look. Some of it you don't even really need a drive station to test, just learning the RDP, putting in, getting the software installed, and then just doing a quick test of it. One way you can easily check it is if I go to, there's a built-in command control panel called joy.cpl. If you see your control will show up in that, then you can do the properties and then just start moving things around, and you know that, hey, it actually is passing things through. So you can do that much of a test even without the driver station software installed.
Cool.
Yeah. Anybody's gears turning? Let's get some thoughts. Is there anyone that you think, based on your setup, this is not a potentially viable solution? I'm interested in that feedback to see what maybe needed to be tweaked to have it work for everybody.
Yeah, I'll definitely be trying to figure out how to get it to work in our school district. And if I got some questions or if I learn anything, I'll definitely share that back with the group as well.
Yeah, so the getting an easier VPN setup for a lot of people is going to be the hardest part, I think.
Yeah, that's what I was about to say. It's going to be
Yeah,
the trickiest for us.
Well, while you were setting this up, I actually called up our school IT's guy and was like, what's the chance of me RDPing in with a VPN or RDPing out with a VPN on a student account? And it wasn't looking good off of the top of his head. Security is probably not going to allow. We'll see, but it wasn't looking good.
Yeah, in terms of networking, it's the magic port, and it's only one. Whatever it is you're trying to connect to, that is what you need to be able to hit. Now, naturally, do not expose that to the internet. Lots of systems have been owned that way. Don't do that. But as long as you can get into something where you can hit that port on your drive station, that is your goal.
And I guess maybe one way to go about it too would be is if we had a phone hotspot or some kind of hotspot at the school rather than using the school one, but I'd have to kind of think about how much bandwidth we would go through or how quickly with that.
Find somebody who has Google Fi, and they'll probably be willing to give you a data SIM and not really care about the bandwidth.
That's really cool stuff. Thanks for sharing that, Scott.
Yeah, very welcome, and definitely interested in your feedback. If you guys think it's viable and worth it, then I'll probably do a Reddit or Chief Delphi post on it too, just to share the word, because we're all going to be needing solutions like this.
I agree. All right. Thank you.